Say again?
Let's say hi to Amber.
Can you say hi to Amber? Sure.
Hi, Amber.
Hey, Amber.
Hi.
Hey.
Amber, love you.
Yeah.
Amber.
Woo!
She can hear you, yes. Like, she's not listening right now, but when she watches it later,
She's gonna hear that.
that'd be cool if she could just respond. Hey guys. No work. How's it going?
She's just got
So here, this was one of the examples. Again, depending on which one you had, it was different work. The process is the same. What do I do first?
Divide the two big numbers.
Good. Break them up, because I can't do 98 over 45, so divide them up into two separate things. So here, say again? Which way is faster?
No, which one is that one for?
Today's, there were three different problems, so depending on which one you had. Okay? Again, it's the same process no matter what you had here. Does not change. So at this point, why did I make it 9 and 5 again?
So 9 times 5.
And then 9 is a what?
Common factor. No, round 10.
It's a perfect square.
Perfect square. Okay, let's use our terminology right. Perfect square. 49 is also a perfect square. Can you, Ebony, can you hit the lights, please? So here, if we continue this process, we're going to get negative 5 times 7 times radical 2 in the numerator, in the denominator. Very good. Okay, now at this point we have negative 35 radical 2 over 6 radical 5. Am I done? No, I'm not. I'm actually kind of back to where I was, but now I have smaller radicands. I still have a division problem here, but I have smaller radicands now. Let us go on to the next page. We got okay, now looking at this one, we still have the same process. Get rid of this thing, come on. There we go. Now we want to multiply by our radical of our denominator over the radical of the denominator. So whatever the denominator is as a radicand, we multiply by that value over itself. If you guys can't see it on the screen today, you're welcome to move over. Bridget, if you can't see, you're welcome to move up here. The board's going to be over here. We're going to use the whole period. So at this point in time, the numerator over the denominator. Why did I put 6 times 5? Because radical 5 times radical 5 is just 5. The last step is to simplify. Simplify. We're going to get negative 35 over 30 with a radical 10 up here. What can I simplify 35 over 30 into? Anybody got this
35
one?
over 30?
Yeah.
7 over, negative 7 over 6.
Very good, Jordan. How does Jordan know to do this? What is he doing here? He is he's dividing by 5 and dividing by 5. He's reducing these values by a division of 5. So when they cancel here, you're left with a 7 and you're left with a 6. And now we don't even need to divide by 5 there. Okay? Hold it.
Okay, so let's say if your problem was like,
Come up with a concrete question on that.
2 and a radical something something.
Okay.
4 radical something something.
Okay. You can reduce the 2 and the 4 ahead of time.
What if you didn't like? What if
Well, then at the end you would have to reduce it. It would be left in a non-simplest term at the end, and you would have to reduce it. Like here, Owen. At this point here, where we have this 35 and this 5, we could have reduced these two before we actually went on to this step. What would that have done? It would have made this a negative 7. It would have made this a 1, which would have ended up with negative 7 and 6, which is the same answer. So you can reduce before you multiply, and it makes it easier sometimes.
What if it was like the bigger the top number was bigger than the bottom number? You really didn't want all those decimals.
Well, no, you don't want all those decimals. You reduce it to the simplest terms. If it's something like 12 over 3, then it's just 4. But if it's something like 12 over 8, then it's hard to reduce that. You make it 3 over 2.
What about like 2 and 10?
1 over 5. Or 10 over 2 is 5 over 1. Okay?
We're gonna get to.
You get the idea though?
Yeah, I get it, but is it wrong if you leave it like?
It's not, but I would like you to put it in simplest form. That's why I wrote simplest form on here. Okay? So I would like you to turn things into simplest form. Here's the reason why, honestly. When you take the SAT, the answers will always be in simplest form. So if you get an answer that says 10 radical 7 over 2, you have to know that that's 5 radical 7. Because the answer choice of 10 radical 7 over 2 will not appear. So here, this answer choice up here will not appear as a multiple choice. This will. So by reducing it, you're getting the actual answer you're looking for. Okay?
We're gonna get to one of these quizzes tomorrow, right?
Are we going to do one of these quizzes tomorrow?
Yeah.
Yes. This year was the second try at Concept 5. Okay?
This is the first one, right?
For Concept 5, the second one. You did one on the back yesterday, the multiplication one. Remember on the back of that paper? Look on the back of your handout I just gave back to you. That was the first try at Concept 5.
That was the
This was
homework
the...
one, right?
Oh, I
yes.
mean the division one.
That's it for Concept 5. If you want to do another Concept 5, just come in and make one up.
Oh.
Okay, tomorrow you'll have your assessment on Concept 6.
Oh, yeah.
Okay, your first one on Concept 6.
Oh.
We haven't even gotten to Concept 6 yet, so we're doing it today. Okay? Questions on this process? We're going to start now. Okay, let's start. We're on Concept 6.
Rationalize binomial denominators. Sounds so difficult.
It does sound difficult, but it's actually an easy process today. The wording is just very...
It's very complex. You probably mean like and
So we're rationalizing a binomial denominator. Right here. Bridget? You see? Yes? Everybody else good?
yeah, Jose.
Okay, rationalizing binomial denominators. First of all, like Jordan just said, these words are a little bit, confusing at first. Let's discuss what it means. First, if something is irrational, from concept 1, if it is irrational, it means what?
No pattern.
There is no pattern. Very good. There's no pattern to the decimals. So we're talking about radical 7, radical 8, radical 12, radical 13, but not the perfect squares. So what this means is we are going to have a denominator with a radical in it, like we did yesterday, and we just did on the assessment, but it's going to be a binomial. What does binomial mean? Two what?
Two nomials.
Two nomials.
Two numbers.
Close.
Two radicands.
Close, again, very close. I wouldn't always say radicans.
Two
How about
squares.
this? What is a
Two perfect
trinomial?
square. Three.
3 something. So we're having trouble with the
Three
end part,
numbers.
right?
Three numbers.
Okay.
That are rational.
I can write down
What's
3
a number?
numbers.
Fractions.
That's one. That's 3 numbers, but that's not a binomial.
It's
Three rational numbers.
Generally speaking, a binomial means it has 2 terms. What is a term? Can somebody define what a term is in math?
a term is like
A name for it.
yeah. What do you say? It's like
Like
term is-
two, like when you have a
Give me an example.
equation, you have an equation.
Okay.
It has like
Oh, X and Y.
shut up.
Melody.
It
Better?
has like 2 thingies.
So give me an example, Melody.
Like 2y plus 3x.
Very good. So that's a binomial because it has not just 1 term, but 2 terms. A term is something separated by a plus or a minus sign. Again, a term is something separated by a plus or a minus sign. So this is 1 term, and this is the other
So
term.
the definition of binomial is something that has 2 terms.
A binomial has 2 terms. A trinomial has 3 terms. A polynomial has more than 3 terms, or 3 or more. Poly meaning many. Okay? Poly meaning many.
I mean, no, the binomial.
2 terms. A binomial has 2 terms. And again, a term is something that is separated by a plus or a minus sign. Rosie.
So it could just be like 1 plus 2.
But see, 1 plus 2 you would just combine and make it 3, right? So that we wouldn't consider. Something like this though, instead of 1 plus 2, what about x plus 2? You can't combine those, right? They're not like terms. So this is a binomial here. Okay? So again, something that is separated by a plus or minus sign. And if we can combine them, then we can actually make it into a monomial. But we're going to be working with stuff that you cannot combine. Okay? You cannot combine.
So trinomial would be like X plus Y plus 2.
Sure. Or x squared plus 2x plus 7. Because you can't combine those either, right?
Well,
Okay, again, as long as you can't combine those terms, they each exist as their own term. Now, today we're going to look at binomial denominators. Okay, let's go to the next page here so we can start off fresh. So let's look at something like this. 2 over 3 plus radical 7. The denominator is a binomial, and it is irrational. A binomial, and it is irrational. Okay? Now, today's process will get a little bit complicated. If you're unsure of something, make sure you ask Mr. Carter, or I can walk around and help you on this as I'm going through the problem. So if anybody has a question on stuff, please just wave him over so he knows he's mine to help you. So for this example, what did we do yesterday when we had a radical in the bottom?
We just
You divided the bottom over the top.
Okay, but what was that called? Use better words though. We're all just saying we divided, we multiplied. What do we actually do?
hold on. What do you ask?
What did we do, yesterday when we talked about division? Just simply division, and the thing you were supposed to do on your assessment today.
Simplify.
Okay, you simplify, but what process did you do? Ebony, help us out. I think I heard something over there. I think I heard the right answer.
We multiply by the reciprocal.
Over the.
Right.
Okay, close. We have to speak math, right? If we can't speak math, how can we do it? Yesterday, what we did was we multiplied by the denominator over the denominator. Like if the denominator was a radical 5, remember we multiplied by radical 5 over radical 5?
Yeah.
So all you need to say as an answer is we multiply by the denominator over the denominator. Now, if I do that here, let's see if it works. Okay? Let's see if it works, and then I want to hear what your suggestion is of the way that we can do it every time. So if I just multiply by the denominator over the denominator, let's test it out and see if this actually makes sense. Because this is what we said yesterday, right? We took the denominator, and we put it here, and we put it here. Now, if I have a binomial and another binomial, I have to think about parentheses. What method must I use to multiply the denominators here? To multiply these two.
Foil.
Very good, Olin. I have to FOIL, because these are both binomials. But up top, what can I do?
Multiply.
Good. Or what's the word?
Distributive property.
Distribute. FOIL is the same as box
Outside,
method.
outside.
Did you learn box method, Jordan?
Yeah.
Box method and FOIL are the same thing. FOIL just means multiply first, outer, inner, and last. Okay, so let's FOIL this one. So, and then let's do the numerator first. The numerator is easy. 2 times 3 gives me what?
6.
This gives me a 6. 2 times radical 7. Can I do it?
No.
So I just leave it as plus 2 radical 7. Again, 2 is on the outside of our radicand, or radical. 7 is on the inside of our radical. So 2 and the 7 cannot be multiplied. So we just put them separate next to each other like this. You can't take the 2 and bring it inside and make that a radical 14, because they're separate entities. Okay, this is like having an x, and this is like having a y. Can't really multiply them, but you can write xy, just like we're doing with 2 radical 7.
Do you need the denominator amount?
We're not there yet. We're working on that.
Okay.
So for the denominator, let's FOIL. 1.
For the numerator, I'm talking add the 3 and the 2.
Because see this parentheses around here?
I mean,
It means that you're multiplying this 2 by the whole thing. So if you remember, if you have like 2 times x plus 1, it becomes 2x plus 2. We distribute, right? So we're doing the exact same thing over here. Okay? And again, it comes from this time symbol right here in the middle. Good question. Now, in the bottom, let's FOIL. And I'll do this one step at a time. So first means that we're going to be multiplying this value here and this value here, whatever is the first of each binomial. So what is 3 times 3? 9. So we start with a 9. Now, next is outer for FOIL. So I take the 3 on this side over here now and multiply it by the radical 7 over here. So I get plus 3 radical 7. Again, I can't multiply those, so I just leave it like that.
So at you get 9, you multiplied 3.
It's going to be long. Okay, I think so you were lost. I wanted to make sure.
You multiplied 3 by 3, and then that's what you get.
3 times 3 gave me the 9, and then the 3 times the radical 7 gave me the 3 radical 7. Okay, now I do inner. Okay, we did first, then we did outer. Here's inner. So we're going to multiply this 3 times the radical 7 again. So plus 3 radical 7. And then finally, what does the L in FOIL stand for?
Last.
Last. The last terms are radical 7 and radical 7,
Radical 49.
which is just really
Seven.
7. I'm going to put radical 49 for now, but again, you can just write 7 if you want in your notes. Now, take a look at the process we've performed so far. The radical 49...
We would have to, 49, we would have to reduce it anyway.
Yes, and this is going to become a 7, right? So we can already go like this. If you want to just put a line through here and put a 7, that's fine. Because we know radical 49 is 7. But what's the problem? The whole goal of this process here, the entire goal is to see and say, okay, in the middle two terms here, do they cancel each other out? So for example, we want to get rid of this radical. The whole idea is to rationalize the denominator. These don't cancel though, do they?
I don't know, now you tricked me.
They're both plus signs. What would have to happen for these two middle terms to
Well,
cancel?
they would have to be subtraction.
What would have to be?
Subtraction.
And what would have to be?
Positive.
So if this was a positive over here, this would have to be a negative over here. And then they would cancel, right?
But we're screwed.
But right now, yes, we're out of luck. If we look back to our original though, and all we have to do is this, go back to your original thing, and instead of making this a plus sign, what if we make it a minus sign now?
But wouldn't that be changing the equations?
It would, but you know, if I make this a minus sign now, and I make that a minus sign instead of this plus sign here, this just becomes a minus sign. Agreed? Because the numerator up here, this just changed that to a minus sign. And then what happens is this. This minus sign makes these two minuses, which makes this a minus. And then it also says, okay, well this is a minus. This had to do with what? This was my last and this was my outer. So outer was here. It would also make this a minus sign. So we can use the same process as yesterday, but the only trick here is that this middle sign has to be the opposite of whatever this sign was.
Is that a rule? Or
And that's what we're going to talk about today. That's the whole rule today. But we showed, right now I'm trying to show you where it comes from and why we do this. We want to cancel these middle two terms. And the only way to cancel these middle two terms right here is if these signs are opposites. Again, so if this is a plus sign, this must be the minus sign. If this were a minus sign, this must be a plus sign. Okay? So with that knowledge, let's go on to the next example and finish. We could finish this one because these two would cancel. But let's start a new one with that now that we know it, okay? Now, it's good to know what the term is called that we're talking about now. So let's write something down first.
Wait, what happened?
We're going to start a new problem with that. That was just a test problem. We're going to start a new one and finish it off.
So we're not finishing this one?
The one that we did, just leave for now. We'll start a new one and actually go through the correct method. I wanted to show you where it comes from now, okay? So here, let's define a word called binomial conjugate. Binomial conjugate. And I'm going to define it with the actual expression to make it easier. So A plus radical B and A minus radical B are binomial conjugates. The conjugate just means that it's a plus or a minus. That's all that means. Binomial means two terms. Again, there are two terms here. There are two terms here. They have opposite signs in the middle, which makes them conjugates. Again, the two terms make it binomial. The opposite signs make them conjugates. It's important to know this word because we're going to use this again when we get to quadratics. So please make sure you put a little star next to this so you understand what this is here. All right, now let's actually do a problem. I'll let you take another second to write that one down before I go to the next slide. But let's try a problem and let's do it the right way. So if we have a denominator of something with a plus, let's use a minus. If we have a denominator with a minus, let's use a plus. So for example, let's say 7 over 2 minus radical 5. 7 over 2 minus radical 5. What do I multiply by?
2 minus radical 5.
2 what?
2 minus radical 5 over 2 minus radical 5.
Be careful, Jordan. What did we just say?
Positive.
Positive.
I
Thank
just
you.
said that.
You said
Hey,
Sure.
hey.
it's recorded. Let's find out.
Oh.
So anyway.
Okay, now erase the proof.
That's all right. That's all right. So here, again, please put parentheses. even if they're not there in the problem, because they won't be there in the problem. They're assumed to be there, but it helps you to remind yourself, I've got to FOIL my denominator. I've got to FOIL my denominator.
Just to help.
Yes.
So, you know how you have that last one and it's a negative?
Mm-hmm.
They will both, if that one, they will both have to be positive numbers?
Correct. These are both opposite signs of this denominator. That is correct.
Oh.
And again, Melody, if this is a positive here, this must be a positive because you can't multiply by two different quantities. Remember how if you have a common denominator or you're trying to make a common denominator, you multiply by like 3 over 3 or 2 over 2? It's always the same number, right?
Yeah.
So these have got to be the same things.
Oh.
Because this, as a fraction, is really just what value? What's one number divided by itself? Is this the same number or is this 1? Okay? So you take one number, divide it by the same number, you're always going to get 1. So we're not changing the value at all. Okay? Rosie?
So if it were a positive on the other side.
Then these would be?
Negative.
Very good. Again, opposite signs. These are all opposite signs. This is negative, these two are positive. If this were positive, these two would be negative. At this point in time, can somebody tell me what the numerator would be? The numerator. I'm not worried about
It
that.
would be 14
Slow down. 14 what?
plus 7 square.
Very good, Melody. Plus 7 square root 5. How did she get that? She distributed to both terms again. 7 times 2 gave her the 14. 7 times radical 5 is just 7 radical 5. Again, 7 is like on the outside or an x. 5 is on the inside or it's like a y value. You cannot multiply those two things. Now, in the denominator, since we just learned a minute ago that the middle term is going to cancel, do I have to do all of FOIL here, really? I don't have to, believe it or not. So if I start with first, what's 2 times 2 going to give me? 4. But then if I do outer and then I do inner, what's going to happen to both of those? There's going to be a negative 2 radical 5 and a positive 2 radical 5. So in the end, these middle two terms that come after this, the term that would be here and here before my last term over here, these middle two terms are always going to cancel. And what's going to happen is one of them will be positive and one of them will be negative, and they're going to cancel. If you want me to show you, it's going to be 2 radical 5 and 2 radical 5 like that. But again, they cancel. So with this process, you really don't have to do the outer and the inner part of FOIL. But it's important that you know it only works right here. So don't just, forget FOIL for everything else. For everything else, you got to do all 4 terms, right? First, outer, inner, last. But here, they happen to cancel. Now, the last step is to do last. We've got a negative radical 5 and a positive radical 5, and we are multiplying them. So what's a negative times a positive? It's a negative. So this last symbol here will be a negative. And then what is radical 5 times radical 5?
Radical 25.
Radical 25. But what's radical 25? Okay, so here it's radical 25, but we all know that that's really just 5. So our denominator is really just... What's our denominator? Who can tell me? 4 plus negative 5, or just 4 minus 5. Okay, again, all that's left in the denominator is this 4 and this negative 5 here. So it's really 4 plus negative 5. Okay, and we can simplify in a second. Go on.
I thought the radical would be negative. Like,
On the inside, you mean?
Yeah, that's what I
It's
thought.
only negative on the inside, Owen, if these numbers are negative on the inside. This
Oh,
negative is like
negative.
negative 1 on the outside. This is like a positive 1 on the outside. So you're multiplying negatives on the outside, which gives you a negative on the outside.
That would make it
It's got
imaginary.
it. Very good. And that would make it imaginary. And if we have a negative under the radical, then we have an imaginary answer. Okay? I'm going to continue up here because we're running out of room, but we have enough. It's going to be 14 plus 7 root 5 all over negative 1. Is that agreed?
Yeah.
Again, the denominator is a simple 4 plus negative 5 now. At this point in time, I can distribute the negative 1 and just have a final answer as a numerator. So make a negative 14 minus 7 radical 5. Okay? Again, how do I know these are both negative? They were both positive, and if you divide something by negative 1, it just changes the sign. Like 5 divided by negative 1 is negative 5. 10 divided by negative 1 is negative 5.
So if we left it on as a fraction, like it was there, it would be
It may
wrong.
not appear, like if you would, again, if this was an SAT kind of problem, it may not appear this way. So you might want to put it in simplest terms, and that's why I'm trying to have you practice that. Okay? Now, what I want you to do is try one on your own before we get to the next type, which is a little more difficult. We're only going to do 2 types of problems here. But try one on your own with your group members, please. Try this one. When you're ready to be checked, just ask and we'll come around and check.
Oh yeah.
If you need help in this, please raise your hand. If you finish and you want to put it up, that's fine. Just let me check it first, and then you go put it on the board. Right there, Marcus. You're very close. Right here.
You guys adjust it.
One second, I'll be right back.
That's it.
Because 3 can't go, 3 can go to 12, 3 go to 4. So you cannot go. It has to go into all the coefficients, so it's 12 and 4. Now you can simplify, you can show it still, another way. I'll show it more when I mean it.
Yeah, I have it before.
This is my original.
See what I'm saying? Keep simplifying.
Yeah.
Final answer. That whole part.
No, I didn't have.
Because if you think about it,
Because if we simplify it, the answer should be radical 6.
what you're doing right now is you're trying to simplify the 3 to 12, you have 4, you get 4 minus 4. That's 1. If you try to simplify, 3 has to go into 4 terms. So this 4 can't be divided by 3. So you can't do it. Okay? Now, keep in mind that this is a 4 minus 4 radical 6. You really can't subtract. So even if you could divide these two here, you still can't subtract. This is a 4 minus 4 radical 6. And you can't subtract something without a radical from something with a radical. Okay? So the answer's up. Well done, Claudia. Thank you for helping us.
Yay!
Now again, this 6 came from radical 36. Most of you had that already. At this point in time, the question from some people was, can I simplify? Let's go through this real quick. First, if you can simplify, the denominator has got to be able to go into both terms in the numerator. Again, the radical 6 has no effect because it's inside of a radical, so we can't divide it anyway. But this 3 has to be able to go into 12 and 4. It can go into 12, but it cannot go into 4. So I really can't simplify any further. What I could do is write it this way, and you don't have to write it this way, but you can write it as 4 minus 4/3 radical 6. Now how did I do this? All I did was the 3 into the 12 here gave me this 4, and then 3 into 4 doesn't work, so I wrote it as 4/3 and carried down the radical 6. So this works, or the first one works. Actually, this time either way works, okay? Either one of those are fine. You don't have to break it down any further here, but you can put it in this form. Enrique?
Are they going to be like circumstances where you have to break it down into that way or not?
Very good question. There will be when we get to imaginary numbers, and it's important that we know that when we get there, right? So I would write this down for now, but it's not necessary that you do it right now, but if you want to practice it for later, it's a good thing to practice. Okay? It's a good thing to practice dividing your monomial into your binomial. Again, denominator is a monomial, numerator is a binomial. You divide it into both. Divide it into both. Jose?
How'd you get the 12 minus 4?
Okay, so the 4 by the 3 gives you the 12. 4 times radical 6 is just 4 radical 6. And then I carry down this negative sign right here. You got the denominator good?
Yeah.
All right, let's try the second type. And the only difference here is that the numerator is now also a binomial conjugate, or a binomial, irrational binomial. So let's look at the numerator now.
Are we doing a problem?
Yes, we are. For an example like this, treat it the exact same way. But now, if you look at your numerator, what are you going to have to do in the numerator also? That we did last time.
Subtract or add?
We're gonna have to put addition.
We're going to have to FOIL.
Twice.
2 foils.
Claudia, good job.
I love it.
2 foils call it riddles.
Oh, whoops. Hold on.
Uh-oh.
Make believe that didn't. We're good. Let's try that again.
I love foiling. Foiling is like the funnest thing in the world.
How do I know I have to FOIL? Because I have a binomial here, a binomial here, a binomial here, and here. Okay, now, one second, I'll give it just 1 second. In the numerator, how is it going to be different than the denominator? What's going to be the problem now in the numerator?
You're still going to have a binomial.
We're still going to have what?
That binomial thing.
You're close, not a binomial, but what are we still going to have? It's not going to cancel anymore.
It's just going
Numbers. Whole numbers.
The two in there and out.
Remember the OI for FOIL, and they canceled here, the middle terms? They're not going to cancel up here anymore, because now we have different numbers. So when you get this numerator, it's going to be a long numerator now. Enrique, does that answer your question, or do you have a different one?
So you
Yeah,
have
you
to
know
FOIL
how the denominator and the bottom is like plus?
Mm-hmm.
So it just stays minus?
If this is a plus here, this becomes a minus, and this becomes a minus.
But what
If
about
this were a minus, the top we don't worry about again. The top does not indicate what we're doing, only the bottom does.
That's what
Or
I
is-
So you're gonna FOIL for both?
We're going to FOIL both. Now the bottom, you don't have to do the inner and the outer again. But the numerator, you do have to do it. I'm going to just put the answer up for the bottom. I'll leave you the numerator to try. Okay, the bottom you've seen already. It should be 4 minus radical 49 for the bottom. Because I don't have to worry about the inner or the outer. For the top, make sure you do first, outer, inner, and last. Okay, first, outer, inner, and last. This is good practice, okay, because we're going to be using binomials throughout the entire year.
Yeah, love binomial.
Practice this one, see what you get from the Just make sure you get all 4 steps.
That's the bio.
Now, the denominator you can simplify, the numerator you can't simplify because we get a radicals. Remember, you're just Yep. Take the bottom, what is the bottom? 4 minus 7. Negative 3. Okay. Close that up. Oh, 3 over 9 is 9. All right. 6. Okay, but you're foiling. You're not distributing, you're foiling. See the 4 blue lines to show foiling? This means multiply these 2. Then multiply these 2. Then multiply these 2. Then multiply these 2. Whoa! Did you use box method or foil in Algebra 1?
I didn't use either.
Who's your teacher for Algebra 1?
I was at different school.
Okay, so let me go over this with you then. So FOIL means that we do the first one. So 3 times 2 gives me 6. Okay? Then I do the outer. 3 times negative radical 7 is negative 3 radical 7. Outer simply means this term times this whole term. Inner means I do this one. I'll write it here.
So would it be radical 5, radical 7?
Okay? First, outer, inner, last. You can also use box method. It's the same thing. I can show you that also.
I just think of this because I don't want to get confused.
Okay. For inner, we're going to have negative radical 5 times 2. So it's going to be negative 2 radical 5.
I put plus negative 2. That's the same.
And then for the last,
5 times 7 under the radical gives me.
Radical 2.
And is it negative or positive?
positive.
It's positive.
Yeah.
Because it's a negative and a negative, which makes it positive. Now, once you get to this point, you can simplify your denominator, but can the numerator do anything? You cannot. These are different radicands. This radican, this radican, this radican. They are all different. And you can't break up 35, because there's no perfect square that goes into 35. So the numerator is done. What does the denominator become, everybody?
-3.
This becomes a 7. Very good. And then 4 minus 7 is negative 3. So the denominator is negative 3. The numerator is the same numerator as before. Okay? Again, negative 3, the numerator is the same. Now, here's a little extra question for you. If you can simplify now, you should do it. But take a look. We see this is a 3. There's a 6 it'll work with. A 3 it'll work with. But can it divide into 2?
No.
Can it divide into this 1 that's in front of you, really? So you don't want to simplify that one. Okay? But if you could, you would maybe divide it into all of them. Again, we're carrying over this entire numerator over to the second spot there. Hey, try one on your own to end class, and I'll give you guys your worksheet for homework. You have 3 problems for homework. Try one first and show me you can do it. I'll put this back up in a second.
It's not hard. Just gotta
Follow the steps.
follow the directions.
Try this one with your group, please.
Nothing.
On your own, check with your group, though, please.
Yeah.
All
All these examples. All these.
Get the numerator, guys. You can't just send it comes out of size. So you just write it.
Like the first one.
No, you gotta write it. See how you wrote 2 bracket 6? 2 bracket 6. This is 7 bracket 5. So same thing as arrow. So you take the 7. Plus bracket 30. Minor brackets, right?
Yeah.
That's all of them. Denominator, what happens to Yes, please. Perfect. I know so too.
Here you go, Aaron. This for you.
I'm getting an apple from Boston.
This for you. This for Aaron. You don't know me that well.
What I did?
This one doesn't work. I'm gonna pay
Practice for tonight.
Wow.
Practice for tonight. Again.
Yay!
Tomorrow you're only gonna have one quiz, concept 6, right here in front of you.
Sweet.
Whoa. Yes, one for you, please.
No, you got the denominator right?
Yep.
This is the integration.
No, 43 is 1. Very good.
Oh, no.
Then he got him back. He did.
There you go.
Have a good day, guys. If you need to make anything up, please come by at some point and do so. You do it. Physics and accounting. So, you want that on the worksheet? How do you get in on it? Yes.
You always ask if I had that from some other class.
Thank you for pointing out.
Oh, it's what our class is on today.